The next topic we're going to be looking at is two-dimensional arrays. We have been looking at one-dimensional arrays so far, but what if we want to store something like a matrix or multiplication table? We need a two-dimensional structure. How do we define one? Well, if you have int, let's say r, new int 3, in memory, this is going to give us something like this. So this is 0, 1, and 2. What if we wanted a two-dimensional structure? So a two-dimensional structure like a matrix, it would be something like this, right? So let's actually go. So this would be a two-dimensional structure. So you are going to have rows, and you're going to have, let me do that with a different color, and you're going to have columns. So columns would start, so this is column 0, this is column 1, column 2, column 3, and here you're going to have row 0, row 1, and row 2. So how do we make something like this? So this is two dimensions, so this is how we would do it. So let's call this, I'm just gonna write the name here, data. So I've called this data. So we would have an int. Now this is for one dimension, so if you want to have two dimensions, then we specify that with saying we're going to have two dimensions. Basically, a two-dimensional array, it's an array of arrays. So you have, you're saying you want, for example, in this case, you have 3 rows, and each row contains an array. So we call it data, and this is going to be new. We still want integers, but of course the only difference is we want 2. So here we want 3 rows, so rows goes here, and we have 4 columns. So number of rows and number of columns. So that's number of columns, number of calls. So number of rows tells you how many arrays you have. So here, number of rows tells you how many arrays you have. So in here, you basically have 3 arrays of ints. So in here, you have 3 arrays of integers. Here, it tells you number of columns, tells you how many elements you have, got a little bit messy, in each array. So number of rows tells you how many arrays you have, and number of columns tells you how many elements you have in each array. So in here we have, example, 4 ints or 4 elements in each array. Okay, so this line says, now what does this say in English? This line in English, it says, give me 3 arrays of int, where each array has 4 elements. Now, of course, this is just as is the case with normal arrays. It's initialized to 0. So I guess we made a mistake here earlier on. You know, when I said array R, inside of it, you actually have values 0. So I do apologize about that. So R is initialized to 0. This is also initialized to 0. This was another one of those mistakes that if we were in a classroom setting, you guys would be yelling at me to fix that. And quite frankly, I do miss that about live lectures. So this is what this says. A single array, this is telling you, give me an array with 3 elements. So that's a single array. That's a one dimensional array. A 2-dimensional array says give me 3 arrays of int where each array has 4 elements, meaning 4 integers inside. So that should be pretty clear. Now, I'm pretty much out of room here, but let me just write a couple lines of code really quickly. So if I set R index 1 and I say put that in 7, what happens is we go to R index 1 and we put the value 7 in there. What if I want to put value, let's say I want to put value, let's say I want to put 7 in here. How do I, so it's all about addresses again, right? How do you find that address? Well, you would say go to data, go to row, so row goes first, go to row 1, which is the second row, and go to column 2. And put 7 there. Then you get 7 printed out. It's basically as simple as that. Not much to it at all. Looking at the slides really quickly. So here we have an array of int named foo. Okay, so this is foo. Int, so we have rows are 0, 1, 2, and 3, and columns are 0, 1, 2, 3, 4, and 5. So 6 columns and 4 rows. So if I said foo index 2 and column 4 equals 12, you find that address. So we go to foo, we'll go to the second row, so I mean, sorry, not the second row, the index 2 in rows, so here, and then we want to go to index 4, so we end up here, so this is going to become 12. if I said let's go to foo for index 2 and get that equal to 13, let's see. So we go to foo, we go to row index 4, so 0, 1, 2, there is no 4. So this is wrong. This is going to cause a out of bound exception error, right? Similarly, if I would to say go to foo index, let's say 2, but column 6, I would go here, and so I would go to the second index and I would look for column 6. There is no column 6, so this is also an out of bound error. You could initialize a 2D array. So if you initialize the 2D array, so we have int r equals, and you can kind of see I have 4 arrays. So this is, so we have 4 arrays. That means we have 4 rows, and each array has 4 columns. So we can have, so this is 0, 1, 2, and 3, and then columns 0, 1, 2, and 3. So if I wanted to print 6 out, I would say print ln, and I would say r row 2 column 2, and this is going to print 6. If I want to change 15 to, let's say, 13, the code that I would write is r index 2 and then column 1 equal 13, and there you have it. Let's look at this array in processing. So programmed this array in processing. So you guys recall that if I had an array, so if I had int a equal, it's just a one-dimensional array. If I had this and I wanted to run this, and I wanted to basically say print out what's inside of my array, I could go A. So if I press A, if I run this, first of all, I would get 1, 2, and 3. Let's see what happens if I do it with R. Could I do the same thing with R? Could I get it to print what's inside of R? So this appears, which is really strange, but it's basically the address of that array. So it doesn't work as nicely as for single arrays. I could, however, get it to print one of the arrays inside of R. So remember, a 2D array is an array of arrays. That's basically what it is. A 2D array, so I should write it here maybe. A 2D array is an array of arrays. So in here, if I want to say, okay, well, print out your first array, then it works nicely. Then it prints out 10, 11, 2, and 3. So it prints out that nicely, but it doesn't print the whole thing. What if you wanted to print the whole thing? Well, then you have to do it the old-fashioned way. Using nested loops, because it's a 2D array. So if I wanted to print out the content of A, aside doing the print statement, of course, I could do something like this. So 0, I less than a dot length, I plus plus, and I just print out a dot I. So it's a one-dimensional array, missing parentheses, one-dimensional array. I run, and 1, 2, 3 is printed out. So if I wanted to do a 2D array, I need 2 loops, right? One to go through the rows and one to go through the columns. So let's have that. So I'm going to go through r dot length, and I'm going to have another for loop inside. Now let me ask you something. What do you think r dot length returns? So r, what am I missing? Print ln. R dot length. This is going to tell me how many rows I have, right? So when I run this, it prints out 4. What if I wanted to see how many columns I have in each row? Then I need to specify which row I'm talking about. As we're going to see shortly, it is possible to have different number of columns for each row. So we're going to see this shortly. So if I go r index 0, so it prints out 4. And now, just for the fun of it, let's add another integer here. Now you see it prints out 5. Basically, that's it. So this prints out number of columns in row in first row. So we have the outer loop going through. We have the outer loop going through the column, the rows, and we're going to have an inner loop going through the columns in each row. So j less than r index I, j plus plus, and in here we're going to print r row I index j, and when we printed an entire row, we're going to go to the next line. So let's run with this. I'm missing a semicolon. Oh, so many errors. So this dot length, and you see I'm getting this printed out. I'm not printing any spaces. So if I print a space, so if I say after you print in a number, so you print a number and then give it a space. And let me get rid of my print statement here. So let's run, and that's what we get. So the first row we have 10, 11, 2, 3, 10. Second row we have 3, 2, 1, 0. Third row we have 0, 15, 6, 1. And the last row we have 3, 8, 0, and 4, just like we have up here. So the outer loop goes through each row. The inner loop goes through the columns for each row. So for each row, the inner loop goes through all the columns. So this actually, in memory, looks something like this. This is 0, 1, 2, and 3. This is 0, 1, 2, 3, and 4. And when I fill this in, it looks like this. So it's 10, 11, 2, 3, and 10. 3, 2, 1, and 0. 0, 15, 6, 1, 3, 8, 0, and 4. So basically, when I say R dot length, this is 4 because this counts the number of rows. So this gives me number of rows. On the other hand, if I say R dot length, if I say R index 0 dot length, this outputs the number of columns in row 0, which in this case happens to be 5. So this would output 5. Number of rows is of course 4, right? And if I say R index 1 dot length, this is looking at the number of columns in row 1, so this is 4. So hopefully that's clear for everybody. Let's see one more thing really quickly. So if in my processing, basically I came here and I said, well, in here I have 0, 15, 6, and 1. And if I change this to, let's say, 13, then in my memory diagram, is going to change. So my third index, so index 2, this is going to change to 13 now. And that's what the memory diagram would look like. So let's run this again. Now you see the third line, it has 5 elements. So if I said, so if you look at this, so hopefully you wrote this better note down. I'm going to erase this so I can write other stuff about this. So if I said print R index 1, so row 1 and sorry, actually let's go row 2 and column 4, or fifth column index 4, what would this print? This would print row 2 and 4, so this would print 13. What happens if I said print R3 and column index 4? What happens now? So I go to row 3, column 4, there's nothing there, so this is wrong. This is an out of bound exception, error. All right, thank you. We'll be back with more material.